Okay, we're now going into the last section of the Erlang MOOC first week. And what we're going to do here is talk about recursion. Recursion is the way that we power functions in Erlang. It's the way that we can iterate through data, it's the way that we can traverse data structures and so on. We don't have explicit looping constructs, but we'll see later on that Erlang can implement traditional imperative style loops using a particular form of recursion. But let's get started with the basics. Remember what we did so far. We've seen various sorts of Erlang data types, and we've seen how to define functions and how to define different cases for functions using pattern matching. What we're going to now see is that we can get repetitive behavior using recursion. So let's get started with that. I'm not going to apologise for using factorial. It's a nice simple example, we understand it. You might say it's not practical, but it gives us a good illustration to get going. We'll look at lots of other examples and some quite tricky examples in the exercises to come, but let's get started with this. So the factorial is it's a function on integers. It takes the product of the integers from 1 up to n. So factorial of 6 is 720, for example. And traditionally the factorial of 0 is 1, because you're taking a product of no things. The identity for multiplication is 1. So that's why factorial of 0 gets to be 1. So there we've got a description of what the factorial is. How can we turn that into a definition? Well, we can say quite straightforwardly that second sentence becomes the first clause of our function. Factorial of 0 is 1. What about factorial of n? Well, we can see that if you look at the product up there, it's the product from 1 up to n minus 1. That's factorial n minus 1 multiplied by n. And we can write that as our second clause. So what we've got there is a direct, almost a direct rendering of what we had in English above. So we've got our description of factorial. Factorial of 0 is 1. Factorial of n, for anything else, is factorial of n minus 1 times n. And what's nice about definitions like this in Erlang, they are declarative, they describe what's going on, and we can write out a calculation by hand of factorial of 3. And this is something we can do for any definition in principle, but certainly for simple definitions, you can see how the factorial works. Let me just walk you through that now. Suppose we want to evaluate factorial of 3. Well, that's what we're going to highlight, what we want to evaluate. And what can we use? All we've got is the definition at the top. And that says what factorial of 0 is, so that's not relevant. But it also says what factorial of anything else is. That says factorial of n is n, factorial of n minus 1 times n. So in this case, n is 3, so factorial of 3 becomes factorial of 2 times 3. So there we've got one step of our calculation done. But it's not finished, because we've still got a function call in there. So what can we do? Well, we need to work out, before we can do the multiplication, we need to know what factorial of 2 is. So what can we do there? Well, again, look at the definition. It's not factorial of 0, so the other clause applies. Factorial of 2 is factorial of 1 times 2, so we can rewrite that just like this. So we've replaced the factorial of 2 by that factorial of 1 times 2. We still can't work out the answer, because we've still got a function call in there. So we go around the loop again, we work out what factorial of 1 is. It's not factorial of 0, so it's the second clause again. N now is 1, so factorial of 1 is factorial of 0 times n. We replace it like that. And we still have got a function call in there, but the end is inside, because what we're wanting to do now is evaluate factorial of 0, and that's where the base case holds, and we can replace that function call with a 1. And we get this multiplication, which we can work out to give us 6. Now, of course, you understand that. This is something we've seen before. But what I wanted to get across to you is just this fact that you can take the Erlang definition and write it out step by step in this functional style. And so if you have an unfamiliar definition, you can use the rules of the rules that describe the function as a way of writing out by hand what the evaluation is. And then you see precisely. And the other important thing to see here is that you've got enough information in there to describe every value. Because you know the value at 0, you've got a starting point. And the second clause says, if you know the value at n-1, that is on the left, you can work out the value at n. So you know the value at 0, so you get 1, and the value at 2, and the value at 3, and so on. What we did in the calculation was work backwards. We said factorial of 3 rewrites to something using factorial of 2, which rewrites to something with factorial 1, and so on. But that pattern is very general. So we've got that. You can see how the recursion is used. And in using the definition, we replace the left-hand side by the corresponding right-hand side. And you can see here that because n is a variable, that encapsulates all the cases apart from 0. In the first case, we replace n with 3, in the second, replace it with 2, and so on. Each instance, each time we call the function, we get a new instance of n, a new instance of a variable that we replace. Now, we could equally well apply it to a negative number. Factorial of -3 is going to be factorial of -4 times -3, and the factorial of -4 is replaced by factorial of -5 times -4, and so on. Now, sadly, this is never going to terminate. Try it out if you like, because we never hit the base case. So if we want to make sure this always terminates, factorial we really only want for natural numbers, for numbers bigger than 0, we better add a test. And the way we do that in Erlang is to use a when keyword followed by a test. So what we add here is, for the factorial of n case, we add when n greater than 0. And then there's a question, what happens when we call factorial of -3? And the answer is, we get a failure of pattern matching. So the function just doesn't apply in that case. And this is an example of the Erlang philosophy of let it fail. We don't know what we should do if we know factorial is defined for positive numbers, for 0. We don't know what factorial of -3 should be. So it's not up to us to try and handle that erroneous call. We let it fail, and then the caller will have to deal with it. Now, what we've got here is just a little bit of description of what can go into a guard. Guards follow the when keyword, and they're part of the pattern matching mechanism. So what you can do in a guard is use arithmetical operations and comparisons, Boolean operations, and so on. But you can't put general user-defined functions in there. Can you think why? Well, the answer is that the designers of Erlang didn't want pattern matching not to terminate. They would like pattern matching always to terminate. And so, of course, if you have a user-defined function, it might be something like factorial of -3, it might never terminate. And what the designers wanted to do was to say, if you do a pattern match, if you do a test in a pattern match, it must terminate. You must get an answer yes or no. And so there's this restriction. You can't call user-defined functions. All you can do is use simple calculations. I talked about failure. The other problem is that you might, in pattern matching, have a function that takes a long time to compute. It's clear from these that the guards are always computed quickly. So here's a piece of Erlang pragmatism coming in, that you would like guards to be computed quickly. Now, in fact, we can use what are called case expressions to do a general test, and we'll see below how to do that. And as I said earlier on, the Erlang philosophy for let it fail, if we're writing a process or function to do something and it fails, we let it fail because we want the caller to take responsibility. And it's a very nice design principle. You design things for correct operation, And then other parts of the system will be designed to handle error. But you don't try and build in handling every possible case into your function definitions. So it's not defensive programming, it's offensive programming, if you like. Just let it fail. And the caller must deal with the results. Now, just to be clear, I just wanted to reiterate what I said earlier on about this being a direct description. If you look at the definition, I call it direct because it gives a direct description of what it does. We can read those as saying the factorial of 0 is 1. The factorial of n is the product of the factorial of n minus 1 and n. It's a description of what factorial is. That's a very nice property of recursion, that it can be used to, that our definitions can almost be executable specifications. It's a phrase people use. It's something that comes to the fore in functional programming. We're not changing values of variables and the final values of which compute the thing we want. We are directly describing the answer. Factorial of n is factorial of n minus 1 times n. So that's it. What we're going to do next is get you to do some definitions yourselves, try them out, and then we'll come back and say something a bit about those definitions. So that's it for now.